Hey everyone, welcome back. Today we're diving into Git, the magical tool that saves your job at least twice a week and also ruins your weekend once a month. But before we get into commands, let's slow down and talk about what Git actually is in human terms. It's a version control system, which means it keeps track of every change you make to your code. Think of it like a time machine for developers, but one that actually works reliably, unlike the ones in movies where someone sneezes and suddenly their grandchildren does not exist. Imagine a project is a giant multiverse. Every time you create a new branch, you're opening a new universe where things evolve differently. Main is a primary timeline, the one everyone agrees is stable, the Earth 616 of your project. Commits are events in that universe, like snapshots in time that define how things change. When you create a branch called feature Johnny, you're basically saying, alright, I'm going to open a parallel universe where Johnny was born. And the Git tree, that's the map of your multiverse, showing every timeline, every branch, every point where universes split or merged back together. After Johnny graduated from the university, another branch was created, called feature Johnny 2. Say in initial timeline, he worked at Google. In another timeline, he worked at Microsoft. When two timelines merge, Git tries to combine their histories into one. In our case, it will create a merge conflict. And the developer, as a creator, will have to decide which part of Johnny's life will be still true and which one will be erased. Or maybe some combined version will be created in which Johnny was working as a bus driver. In your base, you literally rewrite in your universe's history so that it lines up cleanly with another one. We're basing feature Johnny 2 on top of feature Johnny, as if you say he was working at Google first, then he worked at Microsoft. Once you get this multiverse idea, Git makes a lot more sense. You can explore new ideas in a branch without destroying the main timeline. You can merge universes when their end result of original timelines doesn't have a conflict. And if something goes terribly wrong, you can time travel back to the previous commit and pretend mistake never happened, which is honestly the core skill of every software engineer. Next, we'll learn how to create a multiverse, the repository, manage timelines, our branches, merge and rebase those timelines, fix mistakes, handle case-sensitive file chaos, and deal with ultimate boss fight, the production hotfix. Let's start by creating a brand new Git repository, because sometimes starting fresh is easier than trying to understand what past version of you was thinking. mkdir, my awesome project, cd, my awesome project, git init. And now your folder has superpowers. Next, without hesitation, create a file. Echo console log hello git, written into index.js. Stage it, git add index.js. And finally commit it. Git commit -m initial commit. And just like that, your first commit is made. From now on, you can blame every mistake on the commit history. It's never your fault, it's the timeline. If you already have a local project and you want to link it to a remote repository, here's how. Git remote add origin your repository name, git remote -v, git push -u origin main. Great, your code is now safely on GitHub, ready to impress future you. Or confuse future you. Mostly confuse. Merging creates a merge commit and preserves the exact history of your branch, including an accidental commit named fix thing that you swore you rename later. Git checkout main, git pull, git checkout feature branch, and then after many days or maybe weeks, git merge main. Rebase, on the other hand, rewrites history. It makes your branch look perfectly clean. A total illusion, but a pleasant one. Git checkout feature branch, git rebase main. But remember, never rebase shared branches unless you enjoy apologizing to your colleagues. One day your colleague comes to you and says, "Hey bro, I've rebased the feature branch. Sorry, but you have to deal with it now." And suddenly Git is looking at you like, "Good luck, champ." Fetch changes. Git fetch all. Backup your local work first. Git checkout feature branch, git checkout -b feature branch local backup. This saves you local commits because we're about to do something extraordinary. Reset your original branch to the new remote. Git checkout feature branch, git reset hard origin feature branch. Now your branch matches the freshly rebased remote. Git doesn't exactly forget your work. It just sweeps it under the rug and pretends it never happened. Next, cherry pick your local commits back on top. Git cherry pick commit #1, commit #2, and so on. With this, everything is restored on top of the new timeline, as if you and your colleague actually coordinated the effort, which of course would be unrealistic. If you commit something sensitive like .environment file, or your plans to hack the Pentagon, something that you can't just show to anyone, you can untrack it without removing it from your machine. Git rm cached secretconfig.env echo secretconfig.env written to .gitignore. Git commit -m stop tracking secret file. Nice. Git removes it, but the file stays, gathering strength for a grand comeback. Here's the Git favorite little traps. The case of the uppercase file name. On your computer, login.jsx and login.jsx are basically twins. On GitHub, they bitter rivals. Everything works perfectly on your machine after file rename, and yet your teammates stare at the screen wondering why the code is not compiling. First, let's add a new file. Echo export default function login that returns login page wrapped in a div, set to a lowercase login.jsx. Git add login.jsx. Git commit -m add login page. Now, let's rename it in a way that fails. Rename it into capitalized login.jsx. Stage the changes. Check Git status. Git says no changes. After those changes, the file only gets renamed locally. But as far as Git is concerned, the file name is the same. If you push this, remote will keep the old name, and your colleagues will start questioning what is real and what is not. Two-step rename workaround. Rename lowercase login.jsx into temp.jsx. Stage it and commit it. Then rename temp.jsx into capitalized login.jsx. Stage it and commit it. It looks silly, but those two commits will stop your teammates from marching into your room with a baseball bat. Another way, avoid case issues altogether with git config. Git config core ignore case false. This makes Git strict about case differences, like a bouncer who only lets you in if your name matches the guest list exactly, down to the uppercase letters. Now let's talk about the classic panic moment. Production is broken. A fix exists in a mainstream develop branch, but develop also contains many unfinished features. We can't release all that chaos into the wild. Create a hotfix branch from main, git checkout main, git pull, git checkout -b hotfix, fix critical bug. Find the fix on develop, git checkout develop, git log one line. Copy the commit hash. Cherry pick the fix into the hotfix branch. Git checkout hotfix, fix critical bug, git cherry pick commit hash. Perfect. Only the correct fix travels with us, not the half-broken feature someone pushed on Friday at 10 p.m. Push and create pull request. Git push -u origin hotfix fix critical bug. Merge into main. Git checkout main, git pull, git merge hotfix fix critical bug. Also, bring the fix back into develop. Git checkout develop, git pull, git cherry pick commit hash. And now the fix exists everywhere, and the bug is gone for good, at least until someone reintroduces it in a heroic feat of copy-paste. And that's it. You now know how to create repos, connect remotes, merge, rebase, survive case-sensitive name disasters, untrack files safely, and cherry-pick your way out of production hell. See you in our next video, and may your pull requests auto-approve, your conflicts self-resolve, and your CI pipeline never fail.